which is having an atomic number 114, was the first time made in the lab, because there are like naturally occurring elements or artificially created in the lab as well. And it is produced when an atom of a plutonium is bombarded with the atomic number of 94 with atom of element Z. The nucleus of one atom of plutonium combined with the nucleus of one atom of Z. This form a nucleus of one atom of fluorine. So we have this element which is having atomic number of 114. How this element is created? It is created by plutonium, which is 94, and another element Z. What will be the proton number of the Z? The proton number of Z, because we want the total to be 114. So if this is 94, so if this is 94, what should be Z? So that should be 20, because 94 plus 20 makes 114. So means this element Z should have an atomic number 20. Which element in the periodic table having atomic number 20? That is calcium. So Z should be a calcium. In which period of the periodic table this element belongs to? So for this, you have to use a periodic table. So this is a picture of the periodic table. Where you find this element? Which period? This is period 1, period 2, period 3, 4, 5, 6, and 7 periods are there. Lanthanide and actinide series are. So you can see 114 here. So which period it belongs to? It belongs to 7th period. So that is the 7th period. Predict the number of outer shell electron in atom. How to predict the outer shell? Again, you have to use a periodic table. Which group it belongs to? Which group it belongs to? That shows how many outer shell electrons. So it belongs to group 4. So group number shows the number of outer shell electron. So how many outer shell electrons will be there? It will have 4 outer shell electrons. So using a group number, you can determine the number of outer shell electron, and using a periodic table, you predicted the group, the period from which it belongs to. State the term used to describe isotopes with unstable nuclei. There are isotopes, so we call them as a radioisotope or radioactive isotopes. That's right. Then this is 286 and this is 289, the nucleon numbers. The proton number is 114, because even though the isotopes are there, isotopes will have the same number of proton, but they will have different number of neutrons. So 114, because these are the atoms, so as they are atoms, they will have the same number of electrons as well. And to get the number of neutron, we take a difference. So 286 minus 114, so 172. And this will be 289 minus 114, so 175. The next is in part E, 1 and 2. Only a relatively small number of atoms of fluorine has been made in the lab, and the properties have not been investigated. It has been suggested that it's a typical metal. What are the physical properties of a typical metal? They are shiny, high melting point, good. You can mention shiny, hard, high melting point, high density. These are the typical. Suggest one chemical properties of its oxide. Because it will be a metal oxide. So what is the chemical property of a metal oxide? Metal oxide can react with, it will be a basic oxide. So if it's a basic oxide, it can react with acid. So it will be a basic oxide, so it can react with acid. You can mention that. Metal oxides can be basic or amphoteric. Basic oxide is shown here in the marking scheme. That's why basic oxide is marked. And then why it's a basic oxide, so it can react with acid. Then we have a period 3 element, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, different are there. Answer the question using these elements once, more than once, or not at all. Is a gas at room temperature and pressure? So chlorine or argon, both are acceptable. Form a basic oxide with the formula of X2O, means it is a group 1 oxide because this valency is -2, so this will be +1. So you cannot mention magnesium. Why you cannot mention magnesium? Because magnesium is +2 and oxygen is -2. So magnesium oxide will be MgO. So the relative, like the formula of the magnesium oxide will be XO. But this is X2O, so means the group 1 is made of atoms which have outer shell, so that's argon, form oxide which cause an acid rain, so sulfur, and is extracted from bauxite, so that is aluminium. Aluminium is extracted from its ore, bauxite, which is aluminium oxide, and iron is also there, trace of iron oxide. Form oxide which is macromolecular structure, so group 4 element, carbon, silicon, but in this case we have silicon, consist of diatomic molecule. So chlorine because it is Cl2, so diatomic molecule is there. Fluorine, predict the physical state of a fluorine at room temperature. What is the state of a fluorine? So it is a gas, right? Then we have a dot and cross diagram for a fluorine as it belongs to group 7. Group 7 share 1 electron. So each will share 1 and unshared will be 6. Write a chemical equation for reaction between sodium and fluorine. So sodium, it is Na. Fluorine, because it's a non-metal, exists as a diatomic. So F2, fluorine symbol is F, not Fl. So fluorine is F and it will form sodium fluoride. So sodium is +1 and fluorine is -1. So sodium fluoride will be NaF. But because the equation must be balanced, so we put 2 here and 2 for sodium. Explain why chlorine does not react with aqueous sodium fluoride. So the reason is that because it is less reactive than fluorine, always the more reactive halogen displaces the less reactive halogen from its compound. So this was page 10 for the periodic table.